Yeah, let's see if we are live or not. Not yet sure. Start in a sec. What else do I need to do? Yes, we should be live. Just need the link for this. And post this to Twitter just in case someone wants to join in. Hopefully someone does. Close this. And close that. Get the link, maybe. Start in a sec. It's asking me if you want to post in this other group, whatever. Well, hopefully LinkedIn algorithm knows what it's doing. Pop it in it as well. See how we go. Okay, so recording locally as well, that's good. So we'll edit it later into videos. By the way, I'm automating videos at the moment, so some of the videos here are being semi-automated at the moment. The editing of it, otherwise it takes forever and it's not nice. I don't want to spend so much time on it, so there we go. So we have, let's jump into things. We have GPT 3.5 and 4. In 4 we have, we'll try that plugin again. It's called the codeulator. That's a nice sounding plugin, but does it really work? It did work kind of last time. We'll try it again. Just from memory, had to use this live share. Had to share this invitation link, copy it to clipboard, send it to anyone, blah blah blah. Okay, of course we trust you, so pop it in here and see what it says. You can't, the bot is actually talking to me, you can't hear that. Let me fix it. It's the OBS, there's funny things with sound.
Great, I have access to your live share session. How can I assist you today?
Okay, it's great you have access, but I don't actually think you do. Are you sure you have access? Can you tell me what the file structure of my project is? So now it's actually using codeulator. It's actually connecting it. Before I didn't actually do it. Pretty sure I had to do that first. Still thinking about it. Still thinking. Okay. Now there was some bug with this. I had to give it read only rights to begin with and then change it to read and write. So we'll do that just from memory.
It seems there was an issue accessing your project's file structure due to a timeout waiting for read-write access.
Right.
You need to grant me read-write access to proceed. Please follow these steps. In your live share session, right-click on my bot in the Live Share Explorer.
Yeah.
Select Make Read Write.
Yep.
Once you've done that, let me know, and I'll proceed to retrieve the file structure for you.
If you wish.
If you encounter any issues, please ensure that you initially selected Accept Read Only when I joined the session, as there is a known bug with live share where the Make Read Write option does not appear if Accept Read Write was initially selected.
Okay. So now it should have great.
Great.
Let me try again.
Let me try again to retrieve the file structure of your project.
Okay.
I've successfully retrieved the file structure of your project. Here it is.
Okay, that is
Directories.
it. Okay,
VS Code.
so we are in.
Well known. Bionicchaos_images.
Okay, we don't have to read all of it. But you get the idea. So let's see which one we're gonna do today. So we should see the bot as well. Yeah, it's somewhere. It's sitting there waiting to read this file. Yes, it's just an example of what we were doing last time, trying to automate the video editing process. Might give it a miss for now. Okay. What do you think the project is about?
IEEG_spectrum_16_chan.
It's trying to guess. Okay, we're using a quota.
Based on the directory and file names, it appears that your project is related to various aspects of biomedical and neural signal processing, machine learning, and possibly web development for visualization or interaction. Here are some specific areas that can be inferred. ECG_feature_extractor, ECG_gen, ECG_simulator. These directories suggest functionalities related to electrocardiogram, ECG, signal processing, generation, and simulation. EEG_gen_2, EEG_data_processing. These are likely related to electroencephalogram, EEG, signal generation and processing. IEEG_spectrum_16_chan, IEEG_spectrum_16_chan_denoise, IEEG_org. These could be related to intracranial EEG processing and analysis. Image_prediction, neural modeling toolbox, style gone to PyTorch. These suggest the involvement of image processing, neural network modeling, and possibly generative modeling using GANs, generative adversarial networks. Chaos analytics, entropy_beta_3.
Okay, that's fine. We were actually doing a DCG review 16 channel thingy. It's not live yet. The folder called IG_2. Let's find that. Okay. Just close all there. Yeah, we have Pandas, Flask, Plotly. Have this just a template of a readme file. Template of a readme file. We have this application. It's probably the most important file there. Have these prompts. And it's actually sitting in IEG underscore 2. It's the name of the project. Let's jump into, okay, let's delete that for a sec. We'll jump into GPT, wait, yeah, that's the plugin, so that's GPT-4. Jump back to 3.5 because it doesn't cost us anything. Let's pop this quickly.
I understand that you are looking for a review and feedback on a code snippet related to intracranial EEG data visualization using a Flask application in JavaScript. Based on the provided information, it seems like you have a Flask application that visualizes EEG data using Plotly and JavaScript. However, the code snippet you've shared is quite incomplete, and there is no JavaScript code provided for review. I'll provide some general feedback on what you've shared. Directory structure. Your directory structure seems to be well organized, with clear separation between static files, templates, and data. This is good for maintainability and readability. Requirements. You've mentioned a requirements.txt file, which is essential for specifying the Python packages required to run your Flask application. Ensure that this file is up to date and includes all necessary dependencies. Data source. You've mentioned that the EEG data is available on https://www.ieeg.org/. Ensure that you have proper permissions or licenses to use this data and that you're complying with any terms of use. JavaScript code. Unfortunately, you haven't provided the JavaScript code, EEG.js, for review. It's essential to review the JavaScript code to provide specific feedback on how the EEG data is being visualized and how the interactivity is implemented. Deployment. The deployment commands you provided appear to be for deploying your Flask application on a web server. Make sure that your server is configured correctly and you have the necessary permissions for deployment. Also, ensure that you have a backup and rollback plan in case something goes wrong during deployment. Configuration testing. It's good practice to run a configuration test, sudo apt-check-del config test, before restarting Apache to catch any configuration errors. If you can provide the JavaScript code, EEG.js, and any specific questions or issues you're facing with the code, I'd be happy to provide more detailed feedback.
Yes, this is what we have so far. Let's pop a couple of right, so let's do this bit. So I'll have this as a prompt. It's a bit long. I don't know how it's gonna take it, but there's a few to solve. Just use the there are a couple of issues to solve. There are a couple of issues to solve. There are a couple of issues to solve. First of all, the window is loading smaller and then becoming larger after 5-10 seconds. Grouping side by side works well. However, overlaying all doesn't do much at all. Couple of issues. Do we need actual names of the functions? Probably not. Can deal with it, right? Okay, let's start with these two. Okay, let's pop this in, see what it says.
It appears you have a Flask web application for visualizing intracranial EEG data, specifically from patients with epileptic seizures recorded using the NeuroVista implant.
That's right.
The application allows users to play or scroll through EEG data, select active channels, and change the overlay options for visualizing the data. There are also options to adjust the window size and the separation of traces on the screen. Window resizing issue. The visualization window initially loads smaller and then enlarges after about 10 seconds. This could be due to a JavaScript or CSS issue affecting the rendering of the plotly chart or other visual elements. The option to overlay all traces on top of each other is not functioning as expected. This could be a problem with the implementation in the EEG.js file or related to the plotly configuration. Investigate the JavaScript and CSS, review the EEG.js and style.css files to identify any delayed rendering or resizing scripts, styles. Check plotly configuration. Ensure that the plotly chart configuration is set to render the chart at the desired initial size. Review the EEG.js file. Check the implementation of the overlay functionality to ensure that it's correctly configured to display all traces overlaid when selected. Test with different data. Sometimes the issue could be with the specific dataset being visualized. Testing with a different dataset could help identify if this is a data-specific issue. Epoch labeling. Implement functionality to allow users to label specific epochs or segments of the EEG data for detailed analysis. Fuzzy logic. Integrate fuzzy logic algorithms for enhanced data analysis or visualization features. Slider max value. Programmatically set the slider max value based on the length or duration of the EEG data being visualized to enhance user interaction. Ensure that the data from NeuroVista is correctly formatted and compatible with your visualization tool. Any inconsistencies in data format or structure could potentially lead to issues in visualization. If you want, I can review specific parts of your code, like EEG.js, app.py, or style.css, to provide more detailed insights or suggestions to solve the identified issues. Please let me know if you would like me to proceed with a detailed code review or if there are specific areas you would like assistance with. Certainly. I'll start by reviewing the JavaScript file, EEG.js, to understand the issues with the window resizing and overlay functionality. Shall I proceed with that?
Right, so it is using the codeulator to access the file. So now, there's the DG JavaScript.
It appears that some parts of the EEG.js file are not shown due to performance reasons.
What?
To provide a thorough review, I need to read specific line ranges. I'll proceed to read the initial part of the file to understand how the EEG data is being handled and visualized. Shall I proceed?
Okay.
From the initial part of the EEG.js file, here are some key observations and potential areas to investigate further. Data fetching and plot initialization, lines 11 to 23, The script fetches EEG data from a Flask endpoint and initializes a plotly plot with the fetched data. It also makes a deep copy of the original data for later use. The resize plot function is called immediately after the plotly plot is initialized. This function resizes the plot when the window is resized. The issue of the window loading smaller and then becoming larger might be related to this function or the initial size configuration of the plotly plot. Color and separation update, lines 31 to 36. The script updates the colors for 8 traces and calls the update separation function to set up the initial separation. This might be related to the sep value mentioned in your project description. Event listener, lines 39 to 41. An event listener is attached for plotly_afterplot, but it's not clear what happens during this event as the function body is not shown in the current excerpt. Investigate resizing issue, review. Review the resize plot function and the initial configuration of the plotly plot to identify why the plot starts smaller and then enlarges. Overlay functionality. Since the overlay functionality issue is not addressed in the current excerpt, we should review further down the file to understand how overlay options are handled and identify potential issues. Explore what actions are taken during the plotly_afterplot event to understand if it has any impact on the resizing or overlay issues. Shall I proceed to investigate these specific areas in the code? If so, which one would you like to start with?
Codeulator. Suppose it can write the code as well, so it's reading now. It's not showing me where it's reading. Just sitting there.
The resize plot function is defined to resize the plotly plot when the window is resized. Here's the breakdown of the function. Line 44, it gets the plot element by its ID, plot. Line 45 to 47, if the plot element is found, it calls the plotly, plots, resize function to resize the plot. The function seems straightforward and should work as expected under normal circumstances. However, there could be several reasons why the plot initially loads smaller and then resizes. Initial plot size configuration. The initial size of the plotly plot might be configured to be smaller, and then it gets resized according to the resize plot function or the container's size. CSS styles. CSS styles can affect the size of the plot container. It would be helpful to check the CSS styles applied to the plot container and its parent elements to ensure they are not causing the resizing issue. JavaScript execution timing. The timing of when the JavaScript code is executed can affect the initial size of the plot. If there are other scripts or styles being loaded asynchronously, they might affect the size of the plot after it has initially loaded. Plotly configuration. The configuration options passed to the plotly plot during initialization, not visible in the current excerpt, might have settings that affect the initial size. Check CSS styles. Review the CSS styles in style.css to ensure they are not causing the plot to resize unexpectedly. Review plotly initialization. Look at the plotly plot initialization code and configuration to ensure the initial size is set correctly. Inspect browser console. Check the browser console for any errors or warnings that might indicate issues with the plot sizing or JavaScript execution. Would you like me to proceed with checking the CSS styles or the plotly initialization code, or do you have any specific areas in mind to explore further?
Okay, proceed with checking CSS and plotly initialization. Let's assume I haven't changed that.
Here's the CSS code from the style.css file. The body of the web page is styled to be a centered flex container with a minimum height of 100% of the viewport height. This ensures that the content is centered vertically and horizontally on the page. The plot container class is styled to have a width and height of 100%, with a minimum height of 600 px. This could potentially be related to the resizing issue if the container's height is being affected by its parent container or other elements on the page. If there's an iframe used in the web page, it's styled to take up 100% of the width and height of its container. Plot container height. The height, 100%, style in the plot container class, line 17, could potentially cause issues if the parent container's height is not explicitly set. The plot container might initially take up a smaller height and then adjust as other elements or styles are loaded. The min height, 600 px, style, line 18, ensures that the plot container has a minimum height, but if there are conflicting styles or JavaScript that adjusts the height, it could cause the observed resizing issue.
So they
The
contradict
body is
something.
styled as a flex container, lines 4 to 8. If there are other flex items affecting the layout, it could potentially impact the size of the plot container. JavaScript interaction. Check if there's JavaScript code that modifies the styles or classes of the plot container dynamically, leading to the resizing issue. Parent container styles. Inspect the styles of the parent containers of the plot container to see if they have styles that could affect the height of the plot container. Browser inspection. Use browser developer tools to inspect the applied styles and layout during the initial load and after the resize to identify any dynamic changes. Would you like to proceed with checking if there's JavaScript that dynamically modifies the styles or classes, or do you have any other specific areas in mind to explore further?
That looks okay. Okay, do that. Essentially, these two things potentially contradict each other.
In the provided excerpt of the eeg.js file, there are functions that update the layout and separation of the eeg traces, which could potentially affect the plot's size or appearance. This function updates the layout based on the selected overlay options. Although the specific details are not visible in the excerpt, it's clear that different layout updates are applied based on the selected option, lines 56 to 72. After updating the layout, it seems to call another function update separation, line 76, to adjust the separation of the traces based on the new overlay option. This function updates the separation between channel waveforms. It likely involves modifying the layout or styles to change how the traces are displayed, although the specific details are not visible in the excerpt. It's important to note that this function is called after updating the overlay options, indicating that the separation of traces is dependent on the selected overlay option. Dynamic style or class modifications. It would be beneficial to see the full content of these functions to understand if they are modifying styles or classes that could affect the plot size. The ellipses indicate omitted content that might contain crucial information. Understanding how these JavaScript functions interact with the CSS styles could provide insights into the resizing issue. There might be dynamic changes applied that conflict with the initial CSS styles. Testing the application with different overlay options and observing the plot's behavior could help identify if specific options are causing the resizing issue. Review full content. To get a complete understanding, we should review the full content of the update overlay and update separation functions. This will allow us to see if there are specific lines of code that modify styles or classes dynamically. Browser inspection. Use browser developer tools to inspect the applied styles and layout during the initial load and after the resize to identify any dynamic changes applied by JavaScript. Shall I proceed to review the full content of these functions to identify specific lines of code that might be causing the resizing issue? The update overlay function is responsible for updating the layout of the eeg traces based on the selected overlay option. Here's a breakdown of the function. Fetching selected option and plot element, lines 52 to 53, it retrieves the selected overlay option from a dropdown, or similar element, with the ID, overlay options. It also gets the plot element by its ID, plot. Checking plot element and data, line 54. It checks if the plot element exists and if its data property is an array before proceeding. Updating layout based on selected option, lines 56 to 72. If the selected option is grouped, it updates the line colors of the traces, lines 56 to 61. If the selected option is overlay all, it sets the line opacity to 0.5, making the traces semi-transparent, lines 62 to 66. Otherwise, it sets the line opacity to 1, making the traces fully opaque, lines 67 to 71. It uses the plotly update function to apply the layout updates to the plot. It calls the update separation function to adjust the separation of the traces based on the new overlay option. Overlay options, lines 56 to 72, the function. The function dynamically updates the trace styles based on the selected overlay option. This could potentially affect the appearance of the plot but is unlikely to be the direct cause of the resizing issue. The changes in line opacity based on the overlay option could affect the visual grouping of traces but are not related to the plot size or resizing behavior. The plotly update function is used to apply style updates. It would be worth checking if there are any unintended side effects or if additional layout configurations are needed to maintain the plot size. Further investigation, since the update overlay function primarily updates the styles of the traces and not the size of the plot container, the resizing issue might be related to other parts of the code or the initial configuration of the plotly plot. Since the update separation function is called after updating the overlay options, it could potentially have code that affects the plot size. We should review this function next. Shall I proceed to review the update separation function to check if it contains code that could be causing the resizing issue?
It's doing some not very useful stuff, but I'll just let it do its thing. Because we don't have any better ideas at the moment.
The update separation function is used to adjust the separation between each traces based on the selected overlay option and the separation value. Here's a breakdown of the function. Fetching separation value in selected option, lines 83 to 84, it retrieves the separation value from an element with the ID, sep value, and the selected overlay option from an element with the ID, overlay options. If the selected overlay option is grouped, it sets the separation value to 4000. This hard-coded value might need to be adjustable for different datasets or visual preferences. It updates the content of an element with the ID, sep value display, to show the current separation value and also logs this value to the console. It retrieves the plot element and checks if it has a data property that is an array. It then maps over the original data to create an updated data array, where each trace is offset by index asterisk sep value.
Yeah, I think we just solved it. I don't know why it's doing too much complicated stuff, not particularly relevant. But it seems like removing this line, minimum height, 600 pixels, solved the issue. So now when loading the page, it's not resizing anymore. Staying at that specific size. The colors do change. It's a bit odd because I told it to use original, the same colors all the time. So I don't know what's up with yeah, when loading, the colors are, so you can see left of one and right of one are not the same color, and then they change to this one. Doing this, removing this line seemed to have solved the issue. Now another problem is the color. To begin with, the color is different, and then it's changing to the colors from the color array. Can you fix that? Yes, it's all this minor stuff. So those the colors I want. There's a color array in the code, 8 colors, and then they repeat for the left and right 8 channels. However, when I load the page, the colors are different. There's some sort of
It
random
seems that
color.
the issue with the colors changing might be related to the initialization of the plotly plot and the subsequent updates that are applied to it. To diagnose this issue, we need to look at the specific part of the JavaScript code where the plotly plot is initialized and where the colors are set and updated. Since the initial part of the file is not shown in the current excerpt, I will need to read the specific lines where the plotly plot is initialized and the colors are set. Shall I proceed with that?
Have the button overlaid on top of this dotty thingy, so I can't press the microphone
The
icon
issue
to
with the
turn
colors
it off.
changing after the plot initialization is likely due to the sequence of operations in the code. Here's the sequence of events as per the provided code. Plot initialization, lines 22 to 23, the plotly plot is initialized with plotly, new plot, plot, data, data, layout. At this point, the traces are plotted with default or initially provided colors. Resizing the plot, lines 27 to 29. The resize plot function is called immediately after the plot is initialized. This is where the resizing of the plot occurs. The colors of the 8 traces are updated using the plotly update function. This is where the colors change to the ones specified in the colors array.
Yeah, that
the colors
sounds
are initially
legit.
different because the plot is first rendered with the default or initially provided colors from the data or layout.
Right.
Then, the colors are explicitly updated to the specified colors in the colors array, line 32. To have consistent colors from the beginning, you should set the desired colors during the plot initialization. You can
Okay.
modify the data or layout to include the desired colors before calling plotly.
Can you
new
actually
plot.
change the code, or?
Here's a modified approach. Set colors during data preparation, when preparing. When preparing the data for the plotly plot, set the colors of the traces according to your requirements. This way, when the plot is initialized, the traces will already have the desired colors. Since the colors are already set during the data preparation, you can remove the explicit color update after the plot initialization. I can help modify the code to implement this solution. Shall I proceed with creating a draft for the code modification?
Okay. Code emulator. No, code emulator? Codeulator. How do you even pronounce this name? It's a funny name. It's obviously working very different from what GPT-4 does, the code interpreter, whatever it's now called, the data plugin thing. But I was not sure in the video they're showing that it's actually modifying the code within Visual Studio Code. But it's good that it's reluctant to do so.
I have prepared a draft of the code modification to address the color issue. Here are the changes. I removed the explicit color update after the plot initialization. This ensures that the colors are not changed after the plot is rendered. I added code to set the colors of the traces during the data preparation phase. Each trace's color is set according to the colors array before the plot is initialized. Please review the changes. If they look good, I can apply them to the file.
Right.
If there are any adjustments needed, let me know. Shall I apply these changes?
Wait. Not sure. Don't apply any changes, but so why are you removing the colors? Let's see. Remove the explicit color update. Plotly update. Why now you're not showing the lines? Okay, let's create a copy as we usually do. We normally, we have very basic version control. We have a working code and broken code. So shall I apply that line? Okay, go for it. Layout is pretty annoying. Doesn't let me turning off the microphone once it's going. It still can't press the button. Some sort of layout issue. Did it just
The
change the
changes have
code?
been applied to the eeg.js file. Now, the colors should be consistent from the beginning, as they are set during the data preparation phase before the plot is initialized. Please check the behavior of the plot colors in your application to confirm if the issue is resolved.
Right, so
If there are any
AI,
further adjustments needed or other issues to address, feel free to let me know.
so AI just modified my code directly into in Visual Studio Code. That's a bit creepy, but that's the new normal, I think. So it removed the colors. Don't get it, but did also like modify it and actually save the file. It's a bit odd, but okay. So reloading the page. Yeah, those are the colors that we actually want. We want them to repeat for the first 8 channels and the next 8 channels. Yeah, now those are the default colors. And it's just using the default colors. That kind of defeats the purpose, isn't it? Right, so it didn't actually understand what I meant. So what did it? So you can see who modified the code. Share terminals. How do I only see? Right, so in here I can see where it is sitting now, the AI. So it modified that bit. Save original data. Did something else, didn't I? Okay, this is super weird. I can't even revert back to what it was. Okay, like we have a copy. It's weird that it's not actually showing exactly what was modified. Yeah, these colors. Yeah, it's a bit weird. It just removed code for no apparent reason. Okay, let's just go with it for a sec. Okay, this is the change you made is not quite right. I do want the original color array, the 8 colors. I want them to always be used for the first 8 channels and again for the second 8 channels. Please bring them back and correct it so the colors are used when the page is loaded. codeulator. Accessing my thing again. Would also be good to see what exact changes it's making. So it's bringing the colors back.
I apologize for the confusion. I have reintroduced the colors array and ensured that these colors are applied to the traces during the data preparation phase before the plot is initialized. This should ensure that the first 8 channels use the colors from the colors array, and the same colors are reused for the next 8 channels. Here is the change. This code will ensure that the colors from the colors array are applied to the traces when the page is loaded. Shall I proceed to apply this change?
Okay, can apply the change. Let's see how it's actually. Will I be able to see it's doing it, or it's going to be too fast? Right, it's writing stuff here.
The changes have been applied to the eeg.js file. Now, the specified 8 colors from the colors array should be applied to the first 8 channels, and then reused for the next 8 channels right when the page is loaded. Please check the application to confirm if the colors are now appearing as expected when the page loads. If there are any further issues or adjustments needed, feel free to let me know.
The colors are applied correctly now, but only after a few seconds after the waveforms are loaded on the page. To begin with, it seemed to have the default color still. But it will probably be going until GPT-4
It seems like there
times
might be
us
an
out.
asynchronous operation or a delay in applying the colors after the plot is initially rendered. This could be due to the sequence of script execution or some other asynchronous operation that is causing the delay. To diagnose this, I would need to look at the entire sequence of operations from the initialization of the plot to the application of colors and any other asynchronous operations that might be affecting this sequence. Shall I proceed to review the entire JavaScript file or focus on specific sections to identify the cause of this delay in applying the colors?
Okay. Yeah, it's like I wish it was doing it without me.
It appears that I can't view the entire content of the eeg.js file at once due to performance reasons. I'll need to review specific sections of the file to diagnose the issue. I suspect that the delay in applying colors might be related to the way the plotly plot is being updated after it's initially rendered. It could be due to the sequence of script execution, event listeners, or other asynchronous operations. I'll start by reviewing the beginning of the file where the plotly plot is initialized and where event listeners are attached, as this might give us insights into the issue. Shall I proceed with this approach?
Okay. So why the performance issue? GPT-4 doesn't have that issue.
The
So
beginning
where's
of the
that issue coming from?
JS file contains the setup for fetching plot data and initializing the plot. Here's the breakdown. A variable original data is declared to store the original data.
Yeah.
Once the data is fetched and parsed, a deep copy of the data is stored in original data. An event listener is added to ensure that the DOM is fully loaded before executing the subsequent code. It checks if the application is running on localhost and sets the base URL accordingly. It fetches plot data from the Flask application using the Fetch API. The data is then parsed into JSON format. The delay in
Doesn't seem
applying the
related.
colors might be related to the asynchronous nature of fetching and loading data. The plot might be getting initialized before the data is fully loaded or before the colors are applied. The colors are applied after the data is fetched and parsed, but if there is a delay in this process, the plot might be displayed with default colors initially. We should look further into the code where the plot is initialized and the colors are applied to understand the sequence of these operations. We should also consider any asynchronous operations or event listeners that might be affecting the timing of color application. Shall I proceed to review the section of the code where the plot is initialized and the colors are applied? The section of the code where the plotly plot is initialized and colors are applied is as follows. The colors are applied to the traces using the colors array before the plotly plot is initialized. However, there is a redundant loop that applies the colors twice, lines 25 to 27, which can be removed to clean up the code. The plotly plot is initialized with the plotly new plot function, using the data with the applied colors and the layout from the fetched data. The resize plot function is called immediately after the plot is initialized. The update separation function is called to set up the initial separation of the traces. An event listener is attached to the plotly_afterplot event. However, it seems incomplete as it doesn't do anything with the plot data. The colors are applied before the plot is initialized, so theoretically, the plot should be displayed with the correct colors from the start. The delay might be due to the browser rendering process, the plotly_afterplot event, or other asynchronous operations not visible in this code snippet. Optimize color application. Ensure that the colors are applied efficiently. Removing the redundant loop, lines 25 to 27, can be a start. Investigate asynchronous operations. Check if there are other asynchronous operations or event listeners affecting the rendering of the plot. I can create a draft to remove the redundant loop for color application as a starting point to optimize the code. Shall I proceed with this, or would you like to explore other parts of the code or potential solutions first?
Yeah, I don't have any potential solutions, so we're following AI participant in the code. Does it mean right? So it's red that bit. Now it's doing something.
I have prepared a draft to remove the redundant loop that applies the colors. This optimization might help in ensuring that the colors are applied more efficiently when the page loads. Here's the change. Shall I proceed to apply this change to the eeg.js file?
Yeah, I want to see how it does it.
The redundant loop has been removed from the eeg.js file. This should help in optimizing the color application process when the page loads. Please check the application to see if this change has any effect on the initial color application delay. If the issue persists or if there are any other aspects you'd like to explore or optimize, please let me know.
Okay, let's reload this. The colors should be, that left one should be that red. No, it's the blue. And then red.
I apologize for the inconvenience. It seems we need to delve deeper to resolve this issue. The delay in color application might be due to asynchronous operations, event listeners, or the sequence in which scripts and styles are loaded on the page. We can explore a few more areas. Event listeners. Check if there are event listeners that might be affecting the initial rendering of the plot. Script loading sequence. The order in which scripts and styles are loaded on the page can sometimes affect the initial rendering. We can review the HTML file to check the order of script and style loading. Asynchronous operations. Review if there are other asynchronous operations or delayed executions, like set timeout or set interval, that might be affecting the initial color application. Which one would you like to start with, or is there a specific area you'd like to focus on?
Do the script loading sequence. Codeulator. Right, it's reading the HTML now.
The script and style loading sequence in the plot HTML file is as follows. The CSS file is linked in the head section of the HTML. The Plotly JavaScript library is also loaded in the head section. Another JavaScript file, script.js, is loaded at the beginning of the body section. The eeg.js file, which contains the code for initializing and manipulating the Plotly plot, is loaded towards the end of the body section. The eeg.js file is loaded after the Plotly library and the custom script.js file. This is generally a good practice to ensure that libraries and dependencies are loaded before custom scripts. However, if there is code in script.js or other parts of the HTML that rely on or manipulate the Plotly plot, it could potentially cause a delay or override the initial settings applied in eeg.js. Review script.js. We should review the content of script.js to check if there is any code that might be affecting the Plotly plot. Check inline scripts. Look for any inline JavaScript code in the HTML that might be executing before eeg.js is loaded.
What?
Shall I proceed to review the script.js file to check if there is any code that might be affecting the initial color application on the Plotly plot?
This would be bizarre, because if it's okay, it would not be able to find script.js because it doesn't exist. I don't know where it came with that name from. That's super weird. What?
The script.js file contains JavaScript code for handling the display of a menu based on the window width and the state of a toggle element. Here's the breakdown. Two variables, toggle and menu, are declared to reference the toggle element and the menu element, respectively. An event listener is added to the toggle element to change the display style of the menu based on the toggle state and the window's width. Another event listener is added to the window to adjust the display style of the menu based on the window's width and the toggle state. The
should be related.
JS file is focused on handling the display of a menu and does not appear to interact with or affect the Plotly plot or its colors. The issue of the delayed color application on the Plotly plot is unlikely to be caused by the code in this file.
Yeah, that's right.
Review other parts of the plot HTML file for inline scripts or other elements that might affect the Plotly plot. Investigate if there are asynchronous operations or specific configurations within the Plotly initialization in the eeg.js file that might be causing the delay. Which option would you like to explore next, or is there a specific area you'd like to focus on?
Yeah, and this rate will quickly reach the quota.
I can only view a portion of the eeg.js file at a time. To investigate asynchronous operations or specific configurations within the Plotly initialization, I'll focus on the section where the Plotly plot is initialized and configured. Shall I proceed with this approach? In this section of the eeg.js file, the Plotly plot is initialized and configured. Here's the breakdown. The colors are applied to the traces using the colors array. However, there is a redundant loop that applies the colors twice, lines 25 to 27, which we previously removed. The Plotly plot is initialized with the Plotly new plot function, using the data with the applied colors and the layout from the fetched data. The resize plot function is called immediately after the plot is initialized. The update separation function is called to set up the initial separation of the traces. An event listener is attached to the Plotly_afterplot event. However, it seems incomplete as it doesn't do anything with the plot data. The colors are applied before the plot is initialized, so theoretically, the plot should be displayed with the correct colors from the start. The delay might be due to the browser rendering process, the Plotly_afterplot event, or other asynchronous operations not visible in this code snippet. Investigate Plotly_afterplot event. We need to understand what happens during the Plotly_afterplot event. If there are operations during this event that modify the plot, it might be the cause of the delay. Check plot initialization. Ensure that the plot initialization and color application are synchronous to avoid any delays. Would you like me to investigate the plotly_afterplot event further or look into other parts of the code to understand the sequence of operations during the plot initialization?
Yeah, just check the same thing in Firefox. It works in the same way, so I don't think it's a browser thing. It's somehow selecting default colors before applying the colors that we selected.
In this section of the eeg.js file, there is an event listener for the plotly_afterplot event and functions to resize the plot and update the overlay. Here's the breakdown. An event listener is attached to the plotly_afterplot event. It retrieves the plot data but doesn't seem to do anything with it. This part of the code is incomplete or not affecting the plot directly. A resizePlot function is defined to resize the plotly plot when the window is resized. It calls the plotly plots resize function to adjust the plot size. An update overlay function is defined to update the layout based on the selected overlay options. It's prepared to make updates but doesn't contain the actual update logic in this snippet. The plotly_afterplot event listener doesn't seem to be the cause of the delay in color application, as it doesn't modify the plot or its colors. The resizePlot and update overlay functions are defined but not executed in this snippet, so we need to see where they are called and how they might affect the plot. Further review of plotly_afterplot event. Although it doesn't seem to affect the colors, we should ensure there are no other listeners or operations tied to this event elsewhere in the code. Check where functions are called. We need to see where resizePlot and update overlay are called and how they interact with the plot. Shall I proceed to look for other occurrences of the plotly_afterplot event, or where the resizePlot and update overlay functions are called and executed in the code?
Just want to see how it actually works. Can actually solve anything by itself. Doesn't seem to be very experienced.
In this section of the eeg.js file, there is a function to update the separation between channel waveforms and some event listeners. Here's the breakdown. The update separation function is defined to adjust the separation between channel waveforms based on the selected overlay option. It contains conditional statements and updates the display and prints the current separation value. Event listeners are added, but the details are not visible in this snippet.
Okay, I don't care about.
Explore further to understand the nature and impact of these event
You
listeners.
just read the whole file like GPT-4
The update
could.
separation function is focused on adjusting the separation between waveforms and is unlikely to affect the initial color application.
No, it's unlikely.
The event listeners could potentially impact the rendering of the plot, depending on their nature and execution timing. Explore event listeners. We need to explore further to understand the nature and impact of the event listeners added in this section of the code. Check for other asynchronous operations. Continue exploring the code to identify any other asynchronous operations or delayed executions that might affect the initial color application. Shall I proceed to explore the event listeners in detail and check for other asynchronous operations in the code?
Okay. Did it read most of the code? Or I think it does. It did by this stage, but yeah.
In this section, event listeners are added to handle the resizing of the plot and the updating of the overlay and separation between waveforms. Here's the breakdown. An event listener is added to the window object to call the resizePlot function whenever the window is resized. This ensures that the plot is resized accordingly to fit the window. An event listener is added to the overlay options element to call the update overlay function whenever the overlay option is changed.
Yeah, that's working okay.
This updates the overlay of the waveforms based on the selected option. An event listener is added to the sepValue element to call the update separation function whenever the separation value is changed. This adjusts the separation between waveforms based on the selected value. Errors during the fetch operation are caught and logged to the console. The event listeners are specific to resizing the plot and updating the overlay and separation. They are unlikely to directly affect the initial color application to the waveforms. There are no other asynchronous operations visible in this snippet that could potentially delay the color application. Review initial plot rendering. Go back to the section where the plot is initially rendered and colors are applied to see if there's anything we might have missed. Explore further. Continue exploring the code to identify any other potential areas that might be affected